Welcome to the Building Science Podcast.
Welcome to this. Welcome to the
Building Science
Building Science
Podcast.
Welcome to the Building Science Podcast.
Bringing the human factor to architecture and design.
Brought to you by Positive Energy in Austin, Texas.
Hello and welcome back, everybody. Welcome back to the Building Science Podcast. I'm Kristof here, as usual, with my coffee-drinking sidekick, Miguel.
Hey, everyone.
I'm also here today with Matt Fajkus and Dason Whitsett, two colleagues and good friends. I look forward to talking to them about their new book. But first, let's have them introduce themselves. Matt, let's start with you. Your role, your name.
Sure. I'm Matt Fajkus. I'm an associate professor at the UT School of Architecture and the director of the Sustainable Design Program at UT. And I also run a firm in Austin called MF Architecture.
Oh, yeah, that. Just a little bit. Run a firm on the side. And Dason?
I'm Dason Whitsett. I'm also an architect. I teach in the Sustainable Design Program at UT, and I'm principal architect for a modern micro builder that builds modular homes called Caseta.
We should talk about Caseta too.
Okay.
Maybe a tiny bit more. Tell us what's the basics of Caseta.
So Caseta,
modern micro modular.
Yeah. So we prefabricate these small dwellings that are essentially completely finished before they leave the factory. We're primarily selling accessory dwelling units right now. They get trucked out to a building site, craned into place, you hook them up to the utilities, weld them down to the foundation, and they're ready to go.
Wow.
And we have a big focus on design. We try to build a small building, but we don't want you to feel like you're living a compromised lifestyle. It has everything you need to be perfectly comfortable. We've just condensed the space into a really compact
That's
area.
so cool. Okay, so we're talking today about architectural science and the sun. Maybe we can start right away with Caseta a little bit. So,
Yeah.
And I don't want to make this all about Caseta, but there's this bubble on the end of Caseta that has a lot of glass.
Yeah.
And, so there's some architectural science there that's dealing with the sun. Was there anything specific you had to take into account there?
Yeah, well, it's a really challenging problem. I mean, one key factor that we felt was incredibly important is if you're living in a small space, you need to have plenty of windows, and you need really good daylight. So it feels like there's plenty of space, there's good volume, you're not trapped in this little box. And so we developed what we call the cube, but it's basically this very large bay window type element.
Oh, so just that one area is called the cube, okay.
Yeah, that's the piece that projects off the front.
And it's three sides. Is the top glass as well?
No, although, well, we have one prototype that has glass on the top, and it actually has glass on the floor as well in that prototype, but that proved to have some challenges for actual implementation. So our production unit just has glass on the three sides, but it's pretty sizable amount of glass. And then we have the problem being prefabricated building product. In essence, we don't know how people are going to place these, where they're going to put them, how they're going to be oriented.
Yeah, what climate zone, what orientation, yeah.
Exactly. And we looked at adding projections, overhangs, shading devices. There are a lot of issues with that when you're trying to ship these things and manufacture them. And so what we've arrived at is we use dynamic glass for these units. So that compensates for inattention or situations where you can't orient the building as you ideally would. The one we've used both electrochromic and thermochromic dynamic glass. Right now we're using the thermochromic. And it's essentially self-tinting. You think like transition lenses in glasses. And so it responds to solar heat, and it can tint down to a very, very low transmission level when it's receiving direct sun, and then it automatically goes back to transparent whenever the sun's not.
So it's all automatic. Okay, good. So good. I think that's a good way to actually get into this topic. So the title of the book is Architectural Science and the Sun, the Poetics and Pragmatics of Solar Design. And so I think we could dig into that. Let's talk about the book. But in the context of Caseta, right, human beings have these things called emotions and probably or possibly these things called souls. And that's one of the things, connections with nature and qualities of light, move. But then there's also the pragmatics of, I was wondering how you dealt with the heat. But let's take it in order. So let's assume people know what the sun is. It's this large thermonuclear fusion device radiating all directions, and we catch a narrow slice of it. Anything you would like to say about the sun? What the sun is?
Well, I think that's where the book starts. The book starts by acknowledging that the sun is the basis of all organic existence
There you go.
on this planet. And that being the case, we looked at perspectives on light going back to even prehistoric times,
right.
but especially
Ra,
looking back
sun
to a lot of the Greek optics, for example. This understanding or beginning to grapple with what the sun means, both poetically and experientially, as well as then trying to understand scientifically what is this, what is the matter of which light is conveyed. And so there were a lot of different thoughts up until wave theory, the way we understand the electromagnetic spectrum now. There were a lot of thoughts, and some of them, interestingly, were accurate in their own ways in terms of trying to understand the way that light actually transfers. But conjoined with that is this notion of all these qualitative aspects that have to do with good and bad, and that gets into shadow and shadow theory and the binary opposition of light and shadow, and what light and dark have meant historically and what they still mean in films or even horror films today.
Right.
These types of things still linger through. And one of the things that we recognized is that that shadows were quite strong in architectural discourse and even in architectural schools up until the past 100 years or so. It's begun to evolve, and I would argue, since climate control, we've generally began to think a little bit less about solar geometry overall, and shadows being one of those things that, okay, well, we acknowledge there are shadows, but shadows are considered in architecture generally a byproduct of what you design, rather than something you would think about from the beginning of how will shadows be cast on the building itself, and then as a building participating within a context, how does that begin to work? How do we balance light and dark? So that's a long stretch from talking about the sun in the beginning. But one thing that we do also cover in the book is we talk about vernacular strategies, pre-climate control, how there are different types of organization devices at an urban scale and at a smaller scale to manage the sunlight and to work with it with an understanding that makes a bit of a difference in terms of how you programmatically operate within a building. So, for example, needing to be more flexible in terms of where what types of functions you have in a certain room, dependent upon the temperature and light amount within that given room. So there was a bit of surrendering of program specificity in the past in order to make that work. That goes against the way that we design today. Often we design with very specific programmatic intent and with the expectation you'll have a very controlled amount of light and temperature in every single room in a building at a given time. And so part of this was questioning whether we need to be as rigid, and if there might be some, I don't know, not revival of regionalism exactly, but some at least embracing
I'll
solar
embrace
design
that.
principles.
Go regionalism.
While also, but at the same time, not denying technology.
Yeah.
Not being a Luddite about it either. Not saying technology is all bad, but can technology work in conjunction with those things? And so it does go back to the premise of the sun, acknowledging the sun as the genesis of all things, and therefore possibly being a driver within a larger spectrum of architecture, within a larger design process. So, and then we also recognize that, not to jump the gun with this too much, but this is one of the things that we
go for it, man. You're on a roll.
Well, I'll just finish this thought, and then we can abandon this or not. But so the book was meant to be general enough to be accessible to both architecture students and practitioners and engineers, and not exclusive to any given region. And the book acknowledges that. However, it is rooted in Austin, and a lot of the calculations that were done make some assumptions about showing this within Austin, and that was not by coincidence. Part of that's to do with the fact that there's so much construction and action happening in Austin. One study shows that there are 1 million square feet permitted per day by the planning department in Austin. So 1 million square feet of construction in theory being built. And so the thought is not necessarily that we change the tide all at once, but if you could just move the Titanic a little bit in terms of improving, in terms of performance of buildings, that it could make a huge difference here, especially, but really overall. And so there were a lot of different agendas, as can start to gather. And some of these popped up along the way, but it is meant to span far back in history, but then bring it to the present day and a specific location, but also be able to branch out from that as well.
And actually, Matt mentioned this sort of disconnect that's happened in the world of buildings between people and the sun and their environment in general. And I think it goes even beyond that to just society in general. Probably, due to a lot of factors, but especially because of technology in buildings like air conditioning and things that we spend
electric lighting.
Over 90%, and electric lighting, yeah, exactly. We spend over 90% of our time indoors. We're not out really connecting with the movement of the sun, how it affects, growing plants and weather and whatnot.
Yeah.
One thing I always ask my class at the beginning of the semester is, who came to class using solar energy today? And rarely do I get anybody raising their hand. And then we sort of talk it through, and I ask people how did you get here? And well, some of them drove, and most of them are using gasoline-powered vehicles, which is stored ancient solar energy. Some of them rode their bikes, and where they get the energy to do that? Well, they ate plants and animals that were grown using solar energy. And there always somebody has an electric car, and some fraction of their electricity came from nuclear. So there's a little bit that didn't come from the sun, but basically, by and large, they're getting all the energy that they're doing everything with from the sun, and there are very few people, even of a self-selected group that are studying these topics that are really connected
aware
with
of that.
Yeah.
Furthermore, they're listening to you with carbon ears and reading your book with carbon eyes, holding it with carbon hands. All of that creating the heart of suns.
Exactly. Yeah.
Wild. Okay, so what I really took out of this topic is you guys are designing buildings, and they're put outside, and they're receiving sunshine. And they're, from a pragmatic perspective, there's two managements. And I actually would like to talk about the poetics too, but let's start with the pragmatics, the engineer in me. So there's light and heat. Light management, or heat management would be right. I don't know if you call it light management, but you're creating light that has a sympathetic understanding of how my light sensors work. And they're not just in my eyes, but they're mostly on my eyes. So let's start with heat, which I guess is the topic of shading. And we're in Austin, and the vernacular architecture is shifting. There's a lot of highly glazed. MF architecture is custom residential, right? So is positive energy mainly. So we see a lot of glazing. It means there's a sensitivity to understanding how much heat can come through that, right? How did you handle that in the book, and what would you like listeners to take away, the basics of shading, I guess?
Well, that's something we actually...
have 5 to 10 minutes.
That's something we spend a lot of time on in the book, and we try to make the point that it's really crucial from both a heat management and experiential point of view to consider how the sun is striking your building and coming into your building, because beyond just the energy use, which can be considerable from excessive solar gain, when you get glare, is a huge problem with west-facing windows and makes spaces much less usable. And then you have these kind of follow-on effects where if you have a glary facade, then people are going to tend to close the blinds, and most people, once the blinds are closed, they stay closed. They're not diligently opening and closing them only when the sun is shining out there, and so you're using more electric light and not using as much daylight, which is both energy inefficient and leads to less,
you're not getting the view you paid for.
Yeah, environments, exactly. So it's really a big deal for a lot of reasons, and unfortunately, the design world doesn't really understand shading very well, how to manipulate it, and what's effective and what isn't these days. And we have terrific tools. Practically everybody's using BIM or some form of 3D modeling today, where it'll cast shadows for you, and it's a great analytical tool. the problem with those tools, in my mind, is that they don't really help you figure out what you should do. They can show you kind of what you're getting, but in a non-quantitative way, which can be a little bit hard to, if you're scrolling through shadows throughout the year, it's a little bit hard to know like what time to look at or how to evaluate. Okay, when is the sun coming in? How much is it coming in? These things. So we go through a lot of techniques about, analytical techniques about how to actually analyze and evaluate these factors. I think one of the big upshots is that the rules of thumb in this area are not really very good and incredibly durable somehow.
They are durable, although they're not good.
Yeah, very durable, but also ineffective. And specifically, this idea that practically every architecture student and probably a lot of engineering students have been sort of indoctrinated into that you use horizontal shading for south-facing surfaces and vertical fins for east and west-facing surfaces. And
I've heard those rules of thumb.
Yeah.
Several times.
So it's great that people are thinking about these things. Unfortunately, vertical fins on surfaces that face between west and northwest or east and northeast
The sun's coming up.
are basically completely useless. It's sad because a lot of people have put a lot of effort and a lot of money into implementing these things on buildings, but it just doesn't really work. And we show that both graphically through one thing that I really push is sky dome projections, which is a way of projecting the entire surroundings onto a flat drawing of a dome. You've seen sunpath diagrams, which are generally done in this way, and so you can also project the surroundings of a point in space onto one of these diagrams. And so they're a great way to look at, once you do that, once you superimpose the sunpath onto projection of your surroundings, you can see, for this point in space, when is it going to be receiving direct sun and when is it going to be in shade. It doesn't look at cloud cover, but at least, position of the sun. Yeah, so we have a set of diagrams in here that sort of shows for different shading geometries, how these projections at different orientations look, and then also did a whole series of energy simulations showing the solar gain, on a window at different orientations with different configurations of shading. Basically, it shows that vertical fins, between west and northwest are essentially completely useless.
Right.
And you can visualize this pretty easily. Yeah, like if you kind of like stick out your arms, imagining that those are vertical projections off of your building, and your body is the surface of the building, and then you face west or northwest, and the sun is shining, right between your arms.
Exactly.
They're doing
If you're
nothing.
going to catch a baseball coming to you from the west, you're going to do a horizontal shading structure.
Yeah. So it actually turns out that facing west, it's hard to really do anything very effective. But
because
a
the sun
horizontal
goes very low.
Yeah, because the sun goes so low. But a horizontal will at least give you a little bit more time in the afternoon. At some point, the sun's going to drop in below it, but you get, depending on how deep it is, from an extra hour to several hours of shading in the early afternoon. But at some point, the sun's going to drop below it, and there's really nothing you can do to stop it except have something
active
in front of you, which you generally don't want in front of a window. Although, some people design screens or other kinds of projections that can help. Trees are really effective for that.
And I think it's worth highlighting that this was not only new information that's conveyed in data within the book, but I want to highlight that when Dason's talking about how previously this was only shown in any two dimensions, that a lot of what Dason's work proved out, and there are literally more than 100 diagrams that are very well crafted that couldn't have been done without the software we have today, to show things in 3 dimensions and from new perspectives, to provide a new insight, to actually make more complex diagrams in some ways to make this easier to understand. If that makes sense, rather than having to interpolate between the plan, the section, and different types of things. To be able to show that was a big part of this. So everything that Dason's describing in the book shows not only in narrative description and tabular data through different tables and charts, but then also through 3D renditions that help to explain this in really, really clear, intuitive ways, so that you don't have to understand all of the metaphysics behind the science or all of the science. There, you can begin to draw these conclusions and understand that without having to read it and just believe what you read in the paragraph. That was a big part of the book, and a lot of energy went into that. And I should also credit Greg Arcangeli, who was a research assistant who helped with some of the graphic information as
Oh,
well.
yeah, Greg was fantastic.
But that was an important aspect of this, and a lot of time went into not just stating it as facts to behold, but rather demonstrating that graphically in great detail. At the same time, you can the reader can choose to dive as deep in as they want to into the diagrams, or not, can stay more with the narrative. And so there's a balance between the graphic and written component. But all the things that Dason was saying, the book expands upon and animates in a whole new way that it's very hard to convey in this method.
Dason, I noticed implicit in what you said, and in fact, both of you, I talk about shading, I bring up the subject of shading, and you went to external shading structures, which is fantastic. My hat's off to you, because I don't think people realize as much as an engineer would like that once the heat is in the building, even if it's between the shade and the glass, it is in the building and it's part of the load. Could you talk about that a little bit?
It makes an enormous difference. Yeah, once, especially with modern glazing technology, once that heat is inside, it's almost equally as good at holding it in as it was at holding it out. That's true. Yeah, stopping excess solar gain before it gets to the inside is crucial, and there's kind of an 80-20 rule of thumb that.
Is that a valid rule of thumb now, or just an old?
That's not one that I've actually tested, but it sounds plausible at least, and the numbers may not be exactly right, but it's clear that once heat gets inside the building, the majority of it is going to stay inside the building.
Oh yeah.
If you have if you do have blinds right inside the window, that will reflect a considerable amount of heat back out, but it's not nearly as effective as it would be if the blinds
that's
outside.
absolutely true. Yeah, especially if they're foil faced on the back or something, which is
exactly
less lovely from the exterior.
Right.
Okay, so glass technology. I guess that gets into this, but obviously volumes and volumes and hours could be spent about that. But is that something you take into account when you're thinking about the pragmatics of solar design? You're paying attention to visible transmittance and solar heat gain and U value.
Yeah, definitely. I mean, certainly glass technology has has advanced to the point where it's doing a lot more work for us than what we had 15, 20 years ago.
Yeah.
And here in Austin, the sort of standard glass that's used in most buildings now usually has even the code is a solar heat gain coefficient of 0.3 or 0.29, somewhere in there. And it reduces solar gain considerably compared to conventional clear glass, and so it is true that external shading has less of an impact than it used to, and when a lot of the kind of canonical books were written about this stuff, because the code has basically pushed us in the direction of, well, first of all, assuming that nobody's going to be considering this stuff, so just having reducing the heat gain no matter how you orient your windows. So the impact, there are a couple ways you can approach this. First of all, if you're really being conscientious about it, you can also use a performance approach to your energy compliance. And potentially, if you have exterior shading, you can use higher solar heat gain coefficient glass, so you get more daylight, but you're still using the shading to cut off the direct solar gain. At the same time, if you're using sort of code-compliant glass, shading devices are going to have less impact. And it can be the case that you can't really show, in some cases you may not be able to show, a significant impact from the shading. So it's really important to understand, the actual, not just kind of rely on assumptions about, how you approach these things, but actually to test them and see what the impact is. I would argue that as important, or almost as important as dealing with the heat gain, is making sure that you create a comfortable environment for the occupants, and if you glare is just as important as excessive heat gain. So if people are in a room and you have the sun blaring in through the windows, it's super glary, uncomfortable, hard to look at somebody across the table. And I'm looking at you, Kristof, right now, and I have the sky behind your head, and even right now with no direct sun, it's a little bit hard to see your face because of the contrast.
I can see you perfectly.
Well, exactly, because you're looking at a wall behind me. And if the sun was coming in directly over there, I wouldn't really be able to see you at all.
I'd be a shadow. I'm going to get to you mad about shadows.
Yeah. So creating an environment that creates the right experience for people inside is important, and it also has energy implications, because if the sun's blaring in through the windows, it's uncomfortable. People are going to close the blinds, and then they typically don't open them, diligently the moment the sun, goes off that facade, so that you're getting daylight again, and you're not relying on the electric lights and so on.
I'd like to expand on that.
Please.
So the notion of glass and glass technology, one of the things that is interesting is how that all relates to a larger system. So when we talk about building skins, for example, this the notion of building skins is something that's relatively new, and obviously glass being an important part of that, but it's really part of a larger system. And if you back that out even further, this notion of a building envelope, when previously it used to be facades and then a roof.
Yeah.
But really, there's more of an understanding as those all as one system, and you're only as good as your weakest link with that. So no matter how good your glass technology is, if your roof isn't performing well, or any one of your facades, I think that's an interesting development and part of what this what the book entails, and a lot of the research that Dason was speaking about in terms of understanding solar gain on different facades and the roof. There are a lot of in very clear language and graphically shows the impact of the roof, for example, in different times of year, how much solar gain we have in the roof. So this notion of the building envelope is something that has come into the discourse in a way that wasn't there before. And of course the glass being part of that, but I think it's important to understand that no matter how good of a glass system we have, if we have thermal bridges in other places, or you have other types of places this can break down, you can't shift out of second gear or third gear or whatever that gear would be that the glass gets you to if you don't understand this all as one larger system. And so this is part of the challenge we have now, is we have more specialization within our field, and we have, such as yourselves, we have these fantastic specialists coming on board that are bringing great knowledge. But ultimately, we have to make sure that we all...
It all integrates.
It all integrates, yeah, exactly. If there's a gap somewhere, it just kind of doesn't matter. It's like if you have the best refrigerator you could possibly imagine, best insulated, but you leave the door open, or one panel is missing, it doesn't link with the other panel.
Yeah.
The best refrigerant panels, it all goes literally out the window. And so that I think that's part of what this book it boldly tries to address is the smaller scale, and how does that relate to a larger scale, but all that, of course, related to systems thinking.
Mm-hmm. And so shading as a system, external shading is also durable, passive, there forever for the life of the building. There is some question now, it's not really an open question in the industry, but how long the specs on a glass assembly endure. Like, what is the long-term U value? What is the long-term SHGC? Especially U value, right? It's thought to go down over time, or go up. So the R value,
right? Oh, that makes sense. I hadn't heard that about SHGC, but is the idea that the
frit pattern? I don't know.
Degrade over time.
Yes, that is. It's certainly.
Well, that could be huge. I mean, we're making lots of very large scale policy decisions. Going back to the idea that Matt was talking about trying to make a dent in this giant entity that is the building industry, and using various policy tools to try to drive those smart decisions if those things don't actually last.
So there's external shading, there's internal shading. There's also this thing you mentioned, shadow, right? So I love the concept of shadow, like the Jungian archetype shadow. There's even is it a villain or a hero? The shadow knows. I think it's a hero, right?
I think it was a hero.
But so are you saying, Matt, you were saying earlier, mentioning shadow, So are you designing to achieve certain shadows in the space for the occupants?
I'm suggesting that architecture should, externally and internally, consider shadow patterns as part of the design. Again, not as a byproduct or an afterthought. When Dason mentioned simulation, we're able to simulate what the shadow patterns would be in any given space very specifically. But is that just showing, well, we've checked the box in terms of a certain percentage of illuminance or thermal control? What does that really mean in a bigger picture? And so if I step back philosophically for a moment and come back to the more applicable conversation, when speaking about the philosophy of light and shadow, and even the Greek philosophers, in Plato's allegory of the cave, even, it was this notion that effectively there were two types of people. There were people that were in the cave, that were in the dark, that had a second hand. They could only see shadows.
Right, I remember this. And
tried to construct what was really happening. And shadows helped to provide some information. But then there were people that were in the light, in the know, that really understood the way the world really was. But there was this notion that shadows provided some information that helped to triangulate between those things. But it led to a larger discussion about this notion of the enlightenment. If you're enlightened, you understand, you know. Light was considered knowledge to a certain extent. Mm-hmm. But that only works as long as there is shadow. If we have pure light, if there's only light, everything's washed out or overexposed, then the light doesn't mean anything. It's that light only can mean as much as when there's relief from light. So the shadow is very important, just poetically and philosophically. And I would argue the same thing.
Relief from light. I love that.
And I don't think I've said that before, actually. But you depend upon the two. You depend upon the opposition of light and dark, or light and shadow, and in architectural design, up until the past half century or century, that was a big part of the rigor of learning how to design, was learning how to cast shadows and project that by hand. And it wasn't just to understand, I don't believe it was just to understand, well, here's what the shadows will be on the building. It was as a design tool to decide how much you want to use that as a tool to be part of the facade design, for example, and the same thing for the interior. What are the shadow patterns that are cast on the exterior and the interior, and the same thing at the urban scale. How does this building work in concert with other buildings? How is it shading other buildings? How is it being shaded by other buildings? And so I'm arguing that doesn't need to be the sole driver of a design process, but that it should be an ingredient within it, of thinking of it as a very real aspect. And of course, it's more complex than so for example, in different climates there's more sun or less sun. There are overcast days. It's not as simple as just being able to assume it's always sunny. But in any climate, the sun has some sort of impact, and there will be shadows at certain times. And I think there's room in the academic realm of architecture and professionally to consider shadows more, both in terms of the energy performance and thermal performance, light performance, but also in terms of what does that mean? How are you reading the space? How does that allow for something beyond just thinking of formal composition, just instead of just looking at it in a laboratory the way that I would argue most of us architects typically design something just thinking of it as a specimen in and of itself, rather than a specimen living out in a very specific context and in a very specific microclimate and all those types of things. So without addressing shadows, you're not really addressing all the rest of that. I would say that a part of what's led to that is this notion of modernism, which it is. So the idea of modernism with a capital M is that form follows function, and typically that's been taken to mean programmatic function. Like what is the programmatic function of the building? Let's work outward from there, without thinking about environmental function. But so I think it can fit into the same logic.
What do you mean by environmental function?
Environmental function. How does it perform within its environment? How does it respond to its solar conditions, its temperature conditions? How does it function? How does it perform? How does it function in that environment, rather than just functioning to serve the daily activities of the user?
Right, the program.
Exactly. How does it? So I think function has typically been taken to mean just working towards program.
All about the occupant, not just
right. And which is why I think modernism with a capital M got a bad name after a while, because it was seen as well as serving this programmatic intent, but not really consider whether it has to do with overhangs and there's no regional or vernacular. The whole idea of the international style suggests that there is a form of architecture that you can just stamp out any part of the world. Internationally, you can just stamp this out. We've solved it, which is a bit of the challenge Caseta is facing, to be honest, to a certain extent. But it was based on this assumption that you don't need to respond to your environment. There is an international style that we've developed that's just driven by programmatic function, and so it's not to throw away programmatic function as an ingredient, but I think that as a discipline, there's room to consider environmental function while also considering programmatic function, and the experiential aspect, because the experiential aspect will never be as good if it doesn't consider the immediate microclimate, whether it has to do with the light and the temperature and those types of things.
Yeah, so we've talked many times on the podcast about multiple dimensions of beauty, or like it's like a Sudoku or a Rubik's Cube. And these visualization tools that you so well show in your book, they're actually helping us solve for multiple levels of beauty or performance. And there is something kind of arrogant and brittle about like capital M modernism, the way you're describing it, and putting blinders on itself. Like, no, I'm not going to. Is there? This isn't really the subject of the podcast, but is there a lowercase m modernism that's emerging? Because you were very clear to say capital M modernism.
Well, I mostly meant...
Or is there something else? Is modernism shifting and morphing right now?
No, I suppose I said when I describe...
Capital M.
So when describing capital M modernism, it's talking about a movement that started 100 years ago. Mm-hmm. To differentiate it from contemporary, which means of the recent.
You're right,
so
because
sometimes modern and contemporary are used interchangeably, and to mean just trendy things that are happening out there.
I get it. So there was a period. There's like this classic modernism,
of which strands of that still influence and affect the way we practice today. But it's referring to a school of thought. It's referring to like
Corbusier or something.
Corbusier absolutely is one of the founders of modernism and did an incredible amount of mining in capital M modernism. And so I'm not arguing to throw all that away at all, but arguing that can be then incorporated regionally, and you take a template effectively of what was designed there to really think about questioning structure and skin. That was one of the big parts of modernism, was saying, well, if we move away from load-bearing walls, now we can talk about a building skin that isn't structural. That building skin can be whatever you want it to be, and that was a big breakthrough. And Core began to think about different ways that could affect the way we design space, but most of those weren't environmentally related. They were more to do with thinking
communion
about
with nature, connections to the outside. Or tell me.
Well, it's actually a way to control. One of the big aspects of modernism with a capital M was to conquer nature. Actually,
you're right.
And so the Villa Savoye being a good example of that, it's the machine in the garden. It's not integrated with the garden at all. It's clear out a piece of nature, control it, manicure that all, and then actually just sit lightly on it and be around nature. But there was no interest in really trying to go. It was a way of...
so you're not communing with nature.
I don't see modernism as that.
You're like a voyeur of nature.
I would say, again, that being one of the more vulnerabilities of that. And not that modernism can't do that, but I think it was, to be fair, in a time when technology was, whether it was steel technology to allow for new structure and therefore new glazing types, or energy, the notion of nuclear energy was very promising at that time, and this idea that, well, we probably have infinite energy once we just tap into nuclear energy. There was this mentality that coming out of the two wars that we can achieve anything with technology. So I think it's important to contextualize it in that way. That a bit of this bit of this arrogance came from a genuine optimism of being able to conquer.
Holy moly, we're learning so much.
Right.
Yeah.
If you think about the evolution of the automobile in the past 100 years, in that amount of time since modernism with a capital M started, there's been incredible evolutions in every single way, but I would argue there has not been in the building stock in the same way there have been in automobiles and other types of technology, because there was this assumption that energy would be infinite. I think that was the crux of it, is that we can control nature, we can have climate control, and there was some success at an expense in doing that. But I would argue in its purest form that modernism with a capital M does not commune with nature or its microclimate. It's about trying to take over and create your own artificial world, so to speak.
Wow.
And I think, in talking about the relationship of buildings and the sun, Corbusier in particular is a particularly interesting example because he's this kind of transitional figure. And, he has both examples of his work which probably deal with light and shadow in, a more sensitive and masterful way than maybe anybody else ever has done.
Wow.
And at the same time, other parts of his work sort of spawned, or one of the foundations of this movement, which completely sort of ignored those factors. So you have on the one hand, say, Ronchamp, which does this. It's this chapel on a little hill in France, and it's this beautiful, unique form. But the thing that makes it so special in my mind is the way he kind of tunes these apertures on the inside to allow, it's a very dim, dark space, so very shadowy, but then he allows in, little washes of daylight coming down walls, and then he's got these deep, thick walls where the sun will shine in at certain times, and some of them have stained glass in them, and some of them are clear, and you get these sort of beams of sunlight, sun patches that come through. And it just creates this extraordinary environment. I mean, literally maybe one of the best environments I've ever personally been in. Then at the same time, he did these proposals for these, blocks and blocks of these big towers, kind of set in the middle of, fields, and the towers, they look more or less like, a lot of the towers that we can see downtown today, and were one of the sort of primary drivers of that international style sort of taking over modern design for a long time. So, and one of the great takeaways there is that while we're talking about shadow and shading and controlling the sun, the flip side of that is, our response. I think we have an ingrained response to the sun, and especially when it's contrast. That's usually what we respond to in interior environments, is whether it's in terms of thermal comfort or visuals or light, is if you have uniform conditions everywhere, then that may be nice, but it doesn't seem special. But when you have, a little patch of sun coming in through the window on a cold day, it seems really special. And I think there's still room for that, and in fact, I think it's still necessary to consider those factors. If we're only, we live in a cooling climate here, so our primary concern is trying to control the sun and not let, our buildings just receive solar gain willy-nilly. At the same time, it can be really special to have, a little patch of sun coming in that has some special effect. And I've seen Matt do this in his work. It's something that I've tried to do as well, where you design for, primarily climate-appropriate strategies in dealing with the sun, but you create that one special moment where you very intentionally let in a little bit of sun to, in one case, I designed a chapel that had like a curved wall on the back of the sanctuary, and then a clear story that you couldn't see from the chapel, but it lets, a patch of sun come in onto that curved wall, and it creates some interesting shapes, and it moves around at different times of the year. And it felt like that was an important effect to create, and that the small amount of negative impact in terms of heat gain was acceptable in terms of the overall impact on the project, and it in terms of the qualitative kind of aspects of the project.
Yeah, ultimately, a human being's experience of a space transcends science. I mean, it goes to the deepest part of ourselves. So, and you guys as architects, you're powerful, right? Because you can influence that deepest part of a person. And okay, going back more to the outer level, you mentioned something, Matt, that I found very interesting, and I wanted to explore. Corbusier, for example, one of the things that was happening at that time was structural changes, so that the skin was no longer load-bearing. And it's as though he, as a designer, was like a kid in a candy shop, like, oh, what can I do? I can do all kinds of things. I can do this, I can do that. And it created the seeds for lots of different outgrowths of architecture. And now here we are 100 years later. Well, two things. Here we are 100 years later, being able to stop and go, okay, where were all those seeds growing? Where were the paths leading? And specifically, like, energy use being one. But I think that there's a distortion. I wonder if architects recognize it, where low first cost is absolutely a driver. So the economics of not loading the skin and having curtain walls, and even the labor pool or the lack of craftsman guilds needed to install a curtain wall. And so could you comment on that a little? And I know I want to take it one more direction.
Yeah, this is an interesting one. So with the advent of structural steel, approximately 100 years ago, it was certainly liberating for architects at the time, and almost overwhelming.
Liberating, I love that term, yeah.
So the notion, the free plan and free facade, those terms were used. But again, those were both two-dimensional things. And I think that had to do with a bit of the way that architecture was constructed or designed, conceived of, and how construction documents were done.
It's all done on two-dimensional surface?
Plan and extrude up from plan. And so I think that there were limitations just in the psyche and the way of thinking of how you craft something.
Oh, wow.
Because the free plan is the word you hear the most when they talk about structural, talk about structure liberating the design process. And that's the way architectural school is still thought. We thought of, typically you learn to operate in plan first and understand things planimetrically. So I think it was liberating. At the same time, there obviously is only so much freedom you can work with, and meaning, just for example, the notion of circulation and vertical circulation and staircases. Those conventions don't just go away. You still have to deal with how you convey vertically and horizontally in buildings, and I think to a certain extent it probably was sobering to realize actually you can't. Not everything is up for grabs. Some of what we learned from convention in terms of how you think about ratios of circulation vertically and horizontally still apply from what we would do in a load-bearing building. You have to bring a lot of that over. And the same thing with controlling light. Yes, there was a specific limit to how many apertures you could have in a load-bearing wall for very specific structural reasons. But now, even now you can have a completely glass box building, there's a reason to have some solidity and some opacity to do with light management and privacy and other types of things as well. So this notion of freedom, I think you hit some walls after a while, and you realize, okay, there's still some functional and performative aspects that still translate over that make it not quite as free as you might assume from the beginning. But I do think that what has evolved, I would say, when we think of the work of OMA, for example, and the way that
who is that?
OMA, Rem Koolhaas, a lot of their diagrams and their physical models and explorations are mostly three-dimensional. It's not typically just a plan idea or a section idea. It's then now thinking of that freedom as more of a Rubik's Cube. What are the different elements that can move, and I think that's all part of the same thread of thinking of now that we have this freedom, what can we do? But I would argue that most of that, including the work of OMA, which is very accomplished, isn't based on environmental response as much. It's based on the crafting a form that performs in a specific way within a city, and then challenging the program and how that experience works. Mm-hmm. And that's not to disparage the work of OMA, but rather just acknowledge how complex of a mission we all have. Yeah. And when you design a building such as the Seattle Public Library, that is a very complex structure that asks questions about how do we design a library in the digital age. That's a very typical question, the type of complex question that OMA might ask. How do you design a library that's not like any other library I've ever seen before, but still has to seem like a library to people that are in the city? And so make it, in that case, it is quite a glass box. It's a glass box that's composed of a diagrid structure where no two floors are identical. It does not extrude it up. It's completely not just conceived of in plan. But there are a lot of complexities that come with that, and it's very expensive to build, it's very expensive to maintain. And so I'm very interested in that when you... So Kristof, when you mentioned this idea of first cost and then later cost, when we talk about sustainability, if you think about the very premise of the term sustainability, it's to sustain. What does it mean for something to sustain, to endure the test of time, and that's one of the most difficult things that we're challenged with, is trying to incorporate technology, knowing that some of that technology...
Right, like books in a library.
Right, even that.
Books are going away, yeah.
But glass technology, you mentioned, for example, trying to incorporate what seems to be the best practices of the time, but considering the fact that disassembly might be required. And what does it mean? Can it actually adapt? And so I think adaptation is one of the bigger aspects of sustainability when we think about designing to endure and to consider upfront costs and later costs. So we have to acknowledge that we don't know everything, and there'll be new discoveries in terms of best practices in the future. And so
humility.
At the basis of it, we have to hope that what we do is at least somewhat reversible. And so the criticism of plastics, for example, creating plastics is, we know that once you create plastics, there's no going back, for example. Just as one example, it's just not too reversible once you create this. But
there's no ecosystem to reuse the plastic.
So trying to figure out what the architectural equivalent of that. What's an architectural type of facade you would make that would be the equivalent of that, to where, well, you've done that and it works now, but 10 years from now we realize that off gases in a certain way or whatever, something or other problem, and now it has to, and it can't be disassembled without all being torn down.
Right.
So there,
like spray foam on OSB on a residential building. How do you get those apart?
Right. So there's this challenge of trying to design in a way where there is a framework and a kit of parts that allows for some flexibility. And I think that's part of the merit of what Caseta is doing.
Yeah. Caseta keeps coming up.
What they're learning from that is that it obviously has to be a kit of parts. Assembly is thought of in a much different way than conventional building, and then likewise, disassembly could be thought of in a similar way. I would assume you could interchange certain parts as you learn more about how things perform, and there's probably something we could all learn from that in proper site-specific architecture as well.
Yeah, I love it. Yeah,
I mean, one of the most interesting things about working on Caseta has been that kind of thing. I mean, we've got to design for a lot of conditions that I'm not used to thinking about as an architect, like transportation and how do you lift this thing, and
total weight.
Very pragmatic.
What does your building weigh, Mr.
Exactly,
Foster?
and all these new constraints. And you were just talking about constraints, and I think there's a often kind of a knee-jerk reaction among people, especially designers, about new constraints, and that's one of the impediments to thinking about the kinds of things we're talking about this in the book and sustainability in general, is that some people feel like they're going to their degrees of freedom are going to be restricted, and they won't be able to do something as good as they otherwise might, and I hope we can start to shift that conversation to thinking of constraints as actually good things that lead to opportunities and challenges, but challenges that can be solved and create some new language of building and what we're doing. There's this great interview that Conan O'Brien did with Jack White, where he talks about the kind of constraints he puts on himself. And they're, of course, completely arbitrary, because he can afford any guitar he wants, but he plays like a $10 guitar that came from Woolworths, and the strings are like an inch off the fretboard. So, but he feels like he feels like that making up these rules for himself about how he's going to create his music and what sort of degrees of freedom he has are actually key to his creative process. And I mean, in my mind, he's one of the most brilliant musicians in generations. Yeah. And but yet he works under all these rules that he makes for himself. And I think when you have those kinds of problems that you have to address, that it actually can be really fun, and it provides the opportunity to look at things in a new way and create maybe something that hasn't been done before.
I think it's fascinating how you mentioned music and Jack White, because the next question I was going to ask was something that you had said, Matt. You talked about tuning the aperture. No, it was you, Dason. You talked about the chapel where the architect tuned the aperture. And if you think about that, like you're tuning the aperture, there's a pragmatic side to that. And there's also, implicitly, you're thinking about the human experience, because the human's going to receive the result of that tuning. And there's a poetic to that. So you guys in your practice, let's not make it so much about your practice, let's make it about this book. So architectural science in the sun, the poetics and pragmatics of solar design. What is it you want the architect or the engineer to really take from how to tune an aperture? Like what do they first start with, and where do they go? It's a big question. It's a bit of a mind bender. But tuning an aperture, what does that mean to you? How about just that? Tuning an aperture.
So one of the underlying...
Aperture being the thing that
right.
lets in the light.
Right.
Let's just make that clear.
So we have very exhaustive and extensive diagrams that talk about apertures based on size, orientation, and latitude, really those main three variables.
Aspect ratio being a part of size, like tall and skinny.
Right. So aspect proportion, so just quantity of aperture, and then orientation, and then latitude where it exists on the Earth. But the intent is not to suggest that there is one way to do something, because I think there's always room for interpretation of how this works. But it's hoping to raise the bar a bit in terms of having a bit of understanding of a sliding scale of impact. So what difference does it make to really increase the aperture on a certain exposure and beyond, and to begin to develop a certain base knowledge in order to be able to make informed decisions.
Like a sympathetic understanding.
Right, because
there's an art and a science.
Well, I believe that intuition is not just some mystical thing that you're born with or that just comes to you. You just had this idea. It's based on some rigor of developing a body of knowledge, and based on that body of knowledge, you then maybe connect a couple of dots and think about something else, and then you're able to make an educated guess. Effectively, that's what intuition typically is. It's an educated guess. It's based on some basis of knowledge. So my main answer to that would be that it's not to suggest that you're supposed to take away. You should always have a 10% aperture facing west-facing facade in this latitude. It's not about that, but just having an understanding of what the impacts are of certain aperture decisions that you make. And in the case of Corp, for example, sometimes there was a decision based on the uniqueness of designing a chapel and the way that space is used, and the performative expectations of what you do within that space are very different than what it would have been in an office building and something else. So it by no means is it trying to be prescriptive to suggest that here is the solution, you follow this formula, and now you know what you should decidedly do. But instead it provides a triangulated view, both in terms of calculations, mathematically and visually and through narrative, to help make informed decisions with apertures.
Yeah.
That's my answer.
Wow.
Yeah, I think that's great. And just to
tuning the aperture,
follow on to that, I mean, going back to the title, poetics and pragmatics, we really see those as two sides of the same coin. Any kind of poetic effect, I mean, we've been talking about Ronchamp a lot. I mean, people walk in there and they're like, wow, this is incredible. This is this magnificent experience. They're responding to some, actual
scientific phenomenon,
quantitatively definable phenomenon. And it's sure. I mean,
there's going to be a certain fluff.
It's hard to write the whole formula for the whole thing, but you can predict how the light is going to come in through those windows and what the illumination is going to be in there. And if you can connect
and how the shadows are going to move.
Yeah, what creates those kinds of feelings and the actual scientific basis for why the light behaves in that way, then you're empowered to actually create those kinds of effects. And you're also not at the mercy of just saying, okay, I want a space with a lot of daylight, I'm automatically going to put in a ton of glass, so I don't know exactly what's going to happen, but I'm going to cross my fingers and hope that all this glass is going to result in a lot of daylight.
Which might be happening.
Yeah, sure. So you can, that is, being able to actually visualize an effect that you'd like to create and then use actual analytical methods to then create that effect, I think would be, maybe how I would summarize tuning, whether it's an aperture or any effect in a building, is moving beyond, sort of a haphazard, guesswork approach to trying to create a certain kind of impact and being able to actually define what that's going to be.
Okay, so I have to follow up on this. So I thought I was going to follow up with a different question, but so I'm an engineer and I'm responsible, quote unquote, for thermal comfort, and it's highly subjective. And you just had a sentence there like, okay, so we know when we're tuning the aperture, we get certain qualities of light and color and movement and shadow and the play of those things. We know what the impact is going to be. Do you mean that's going to create awe or inspiration or contemplative? I mean, good grief, that's all so subjective. Like, how do you know? Is that what architects purport to have some sense, like this amount of shadow causes people to be introspective? Or, I mean, maybe they do. I don't know. I haven't heard this before.
I mean, you might be able to get there. I don't know of anybody who's tried to...
Like, did Corbusier go there or Rorschach go there?
Certainly
or was
not.
it Locke?
No.
Or...
I mean, I think that maybe goes back to the intuition idea that Matt was getting at a minute ago, which was that architects tend to work off of intuition for these kinds of things.
Mm-hmm.
It's
intuition
not like
being trained from experience.
Exactly. It's not like they came out of the womb like having some special ability
There you go.
to figure out how much shadow or how much light or whatever is going to make people feel good, but after having observed buildings and looked at the way things work and experienced these things, you gain more and more skill at guessing, but there's still a lot of guesswork involved. I guess my view would be maybe we'll get there. I'm not even sure whether that really sounds like the right kind of question to be asking, like quantifying, like square feet of shadow that have
it
the
seems kind
given
of
response.
Too sterile to do that.
But at least I think it's a matter of having a vision for the type of effect you'd like to create, and then being empowered to create it. And you might get it wrong. It might not have the kind of psychological impact that you hope, but that's where the intuition comes in, is understanding, how I've responded and how other people respond to places that have a certain kind of effect, and, then sort of hypothesizing, okay, if I create an environment like this, then people will respond positively to it. And it's also not like there's one right answer. I mean, there's an infinite array of good solutions to any problem, and I think it's being able to establish what one of those good solutions would be, and then being able to objectively predict ahead of time whether you're creating what you set out to do or not.
I hear it. So you're saying you go through excuse me, Matt, go ahead.
I was just going to say, I think that the clearest example of that is the work of Louis Kahn, especially the Kemble.
Oh, right.
I think he began with thinking about the experience of the light more than anything else. And there are sketches that he's made where he's sketching the light. He's not sketching the proportion of the space, not sketching, well, here's how the program all lays out in this space. He's trying to sketch the light. And once he felt that he had created that environment in one module, then repeated that module throughout the entire scheme, even at the expense of program. For example, the auditorium, if you took any graphic standards book and took what an auditorium should be proportioned to be, and how it should fit, and how many rows and seats you should have, where the aisles should be, it doesn't fit within his module, but to him the experience of just the light, the proportion of material and the space and the amount of natural light filters, that was more important than the program or anything else. And so I think that was what was the driver in that building. And granted, a museum is a unique typology. Most buildings don't have the freedom to have as much of a how do I say that? I'll just say that there's a more extreme contrast and variation in light in those galleries that you can't get away with in a space where you need to work or one needs to perform surgery or whatever the case is. It can be a little bit more. There can be a larger variation of illuminance. But I would argue that is a perfect example of developing enough intuition to begin to grasp and have some confidence that experience is going to be a nice experience, and let that drive the entire scheme rather than looking at the site plan and offsetting lines from the site plan and designing something just to be a well-behaved urban building in its context. It was starting, I would argue, from the bottom up of an individual person and their experience in that space, and then allowing it to organically grow out from there. So that's the sort of thing, and that's
awesome.
That it gets to the heart of what we hope is integrated into architecture. So it isn't just the pragmatics, that there isn't just a formula, but that's to solve this. But you're also thinking about the poetics, thinking about that experience. What is it like to be in that space in different months of the year, and knowing that it will be decidedly different because throughout the year, so that even someone who lives close to that museum would potentially visit the permanent collection to see it literally cast in a different light as the light changes throughout the year, because it's not trying to control light through electric light. It's allowing the conditions to evolve and embracing that. So that again, sorry, that was a long answer to that, but I just wanted to mention that phenomenological aspect. I think it can happen. But part of the complexity is all the different things we have to think about in terms of building systems now. I think there was a certain amount of, not naivety, but there's a certain, we weren't responsible for thinking about as many things 50 years ago when that building was designed. There wasn't as much pressure to integrate and absorb as many things, that you could focus more on that. I think that we're struggling now, we're being pulled in different directions.
Yeah.
We're gaining expertise in certain ways, but sometimes missing the plot a bit in terms of the experience, because the increase in code, regulatory constraints and other types of things.
And goals, societal goals like sustainability.
Right.
And it's interesting, this the idea of tuning the aperture. So I could regard my experience of the world as a tuned aperture, right? I have certain sensitivities. I'm a sensor system walking around. But then there's this circuitry that notices certain things and perceives it. So I realize that you two, and all the architects that we get to work with, and all architects, I guess, generally, you have chosen, or maybe not chosen, but you've ended up being this tuned aperture where you go to a museum and you might go, oh, this space is making me, or I'm having this feeling in this space. But then there's this maybe more science or pragmatic side, like, well, which way is this space facing? And look at that overhang. And how is this aperture arranged to where I am in the... I hadn't really connected that aspect of design before. And it really stands in contrast to something that you mentioned, Dason, which is it seems like a fact to say that, I don't want to sound irreverent, and I deeply appreciate architecture, but I see these designs that it's like, when in doubt, add more glass, right? And how does that stand into this like sympathetic tuned aperture? How does that juxtapose, right? It seems to be in opposition to it.
It's interesting.
This is maybe the third rail of modern lowercase m contemporary.
Yeah.
design.
Well, I mean, there's a habit, I think, among a lot of designers.
Just one more cookie.
That's kind of the way to address facades and problems, and
is it
kind of an
economic?
assumption that there's going to be light, and you're going to increase the quality of the space, and this idea of transparency that there's a lot of talk about, and my own personal viewpoint is different. Those aren't really the spaces that I tend to respond to. What if the client is...
your client might say, because your client's like, look, there's resale, I'm familiar with beauty as being glazed.
Well, I mean, that's real. I mean, and the convenience of having one subcontractor who can clad the entire building and be responsible for the whole thing, there are all kinds of considerations out there, and it is a real challenge we have, I think, right now, and I don't know what the answer to it is.
Any comments or thoughts?
I like this idea. I hadn't thought about this at a much larger scale, but the notion of transparency and...
Oh, there you go.
So even with the Reichstag, the Berlin Parliament building by Foster and Partners, and one of the things I appreciated working at Foster and Partners in the past was this notion of very heroic moves and a very taking a position on what any type of urban design and any material choice would mean. And in the case of glass, for the Reichstag, for example, being the Capitol building, having this transparent dome was much but about the symbology and the symbolism of this transparent government, and
interesting.
People being able to get up into this glass dome and being able to see down into the council chambers. And yes, it also is an instrument to allow natural light into a chamber that was landlocked in the past and was completely dark. So it does allow natural light into the chamber, but becomes this transparency between the people, and the government in that case. But I think it does speak a bit to that, as something that came out of Modernism with a capital M, of this notion of much more transparency, so I think that's part of it. I also think that it still relates to this hubris of, well, we have double pane and triple pane glass, this argon-filled insulated glass. How can you overdo it? It's still, I think there's still this arrogance that the building technology is catching up enough to where you can't overdo it, which is right to a certain extent. It makes a difference, but I think it's still a hangover from the past 100 years of climate control. That it is, yes, part of the market. It becomes part of the real estate market, and that's sort of what's seen as a luxury home. It has to do with a certain percentage of glazing, which goes in contrast with different regulatory. Different regulations. For example, in Austin, the AGB limit, I think it's 30% aperture is the maximum that you can have in order to qualify. But that doesn't take into consideration other environmental factors, whether you have buildings all around you, shading, or trees, if you're nested within trees. And so there are attempts to try to create some standards and some targets, but those aren't complex enough, in my opinion, to consider other factors as well. So I think there are a lot of different things going on, and I would say probably the biggest thing with all of that has to do with coming back to the liberation of having the column and beam construction, to where when you can do anything with the facade. Architects typically think of that, well, let's think of it as large chunks of solid and void. Whereas, of course, when it was load-bearing, it was always a solid that then would have specific apertures in it. I don't think that we think of apertures in the same way for the most part. Now, it's you thought of it as different, as planes, one plane of solid, one plane of glass. And those both are considered very important, but what it suggests that they're much more equal rather than being a majority of solid and very deliberate precisions, incisions within that. So the same way in architecture school we talk about, we even try to take away the term window. You don't use the term window in architecture school because you don't want someone to have the preconceived notion of just a punched 3 foot by 5 foot window. We talk about fenestration or glazing to liberate your mind a bit. Don't just assume it's going to be some store-bought window, and that's part of what leads to this notion of fenestration or glazing being a big part of any design, I would say, regardless of climate and everything else.
So Matt, that leads me to lots of other questions, which unfortunately we really can't go to. I mean, to think about sustainability, the implications for us as the people responsible for making the decisions on buildings and energy use. That's another topic for another day. But today we're going to circle back, bring this interview to a close, and we're here to talk about your book, Architectural Science in the Sun. And so I guess any final thoughts? Matt, we'll start with you.
Yeah, I think one of the things worth noting is we've talked about a gap between architecture and engineering, and this book attempting to fill a void there. But I think it's also worth mentioning there's often a gap between academy and industry, so between academics and the profession of architecture. So theory might be explored in school to a certain extent, and then but sort of lives there only, and then when getting into practice, it becomes much more, as you get practical, just much more about nuts and bolts and all the things that come with the profession. And I think part of the interest for Dason and I, that's right. So part of the interest for Dason and I is trying to wed those things to a certain extent, to allow there to be a relationship and a connection between those realms. And so within the Sustainable Design program in the School of Architecture, there are great faculty members. It's a small cohort, but great faculty members, including Dason and myself, and now a new dean, Michelle Addington, who has a great expertise in sustainability, particularly in terms of energy flow and dynamics. And I think this comes, the idea of this book comes at a very unique time where there is a lot of awareness, global awareness and local awareness of this topic of sustainability, and how that really begins to affect thinking academically within the school and in the profession. So at our practice at MF Architecture, we're often trying to wrestle with these different types of things and trying to have a larger idea. We're interested in having a larger idea and a thesis behind each of our projects, which relate to some larger sustainable topic. But ultimately, it's understanding that architecture is never just one thing. It has to relate to a bigger system. That's what sustainability is about. Nothing is ever just a one-off that you do at any stage.
Right.
And just like no building is ever delivered as a one-off, as a one-man or one-woman show. It's always a collaboration. It's always about integration to a certain extent. It's about how you understand. You're only as good as you understand the overall system, and architects often are the choreographers of that entire system.
Oh, that's a beautiful way to think about it.
And responsible for trying to bring this together. And that's maybe the way we can make the biggest dent in terms of sustainability, is if you just understand enough about how the system of how a building comes into life, how a building is realized from its conception and the ideas to how it's actually delivered, the more you can make an impact. And so the design itself is really just a part of that, to be honest. What's actually drawn and created is a part of that. And this is what I hope, and I think we hope to convey to students, is yes, your design can make a difference, but it's also about understanding how others think in other disciplines and other trades to ultimately be able to make a bigger impact. So this notion of academics and the profession, if we can begin to create an overlap between those two, and then likewise, so if you might think about that as one axis of a spectrum of academics, complete theory to complete practice, and then if you think about different disciplines, the range of much more technical to more aesthetic. If we can find a nexus in the middle, that's where we can make the biggest difference.
Absolutely.
And so that to me is a way of trying to explain how this all comes together for me.
Wow. Okay, so before you go, Dason, sorry to do this to you.
That was great.
Yeah, that's what I was going to say, is like you guys didn't get the hand gestures or the looks in the eyes that I did live just then, but please rewind that and listen to that again. There's so much in there. I mean, you're a philosopher, you're a poet. That was brilliant. Yeah, okay. Top that, Dason.
I'm not going to try to do that, but I think that was really well put, Matt. And I guess the thing I would add is that in trying to engender that interest out there among people, especially in the world of practice, but also students in academia, and as they kind of make that transition, on that kind of axis between all these different consultants and disciplines that you described, I think some of these ideas don't really have a clear home right now in the way that we tend to practice. Architects have tended to, especially as we're seeing like in your work, they're really starting to engage with mechanical engineers or professionals, bringing that kind of technical expertise even into smaller, single-family kind of projects where it used to be pretty much unheard of.
Right. And even early on, it's SD or programming. Yeah.
Exactly. Yeah, and
hands off to you.
On bigger projects, you're always going to have a mechanical engineering firm, and sometimes you'll have additional sustainability consultants, and you'll have other disciplines as well. But the analytical aspects having to do with how you manipulate the relationship of the building and the sun, I think often kind of gets lost in between those different disciplines.
Or it's already set by the time I show up.
Oh yeah, well that's I think what happens in practice, the majority of the time. So
the lot is this dimension, or
yeah. So those decisions are already made, and I think what we're trying to do is actually show that this information is accessible, and anybody can sit down and learn how to deal with these issues. And it's actually pretty straightforward, especially with the digital tools that we have today, which are, we're operating in a time where we have this extraordinary power at our disposal that just a few years ago it was exotic. And now, everybody who's working in the building industry, has these tools. And even if it's just using your three-dimensional design software, and beyond that, you've got energy simulation tools and all kinds of other things now readily available. And even simplified versions like Climate Consultant is a really great tool that somebody can sit down and learn how to use in 15 minutes.
It's free.
And it's free, and you can get, a previously unthinkable amount of information about your climate, in just a few minutes, and help you make really solid decisions about how you relate to it. And so that's what we I think sort of ultimately hope that we can have. We can contribute to a greater level of engagement of kind of your average building professional with these kinds of topics.
Yeah. Wow. So thank you guys for lively, wide-ranging, very enjoyable discussion. Thank you.
Thank you for having us. It's been great.
And thank you all for listening. We'll be back next time.